Okay, let's try this again. Last time I recorded this, I forgot to press record. And it was great. It was the best video ever. But no, I want to talk today about Wireguard, which is a VPN technology that I didn't actually know much about. Now, you know that I'm a huge fan of SSH. And yes, in a pinch, SSH can be used as a VPN. I have a video up here where I talk about different ways you can kind of weasel into a network using SSH. But for long-term, like stable, consistent, really usable VPN, I've generally, well, okay, I'm old, so I've used things all the way back from, like point-to-point tunneling protocol and then L2TP or whatever it is. Recently, I've been relying on OpenVPN, which works great, but it's a lot of setup and sometimes it's frustrating to get it to work just how you want. I wish that I had the simplicity of SSH with the robust networking of OpenVPN, and boy, do I with Wireguard. Now, Wireguard is so simple and fast and easy that it's surprising how robust it is. There's no authentication, like user authentication. Like, it's not like you log in with your username and password. It only works using a public private key pair. Like, you can log in with SSH using only key pairs and not passwords. It works like that, but the key pairs are the only option. It's also really secure. Part of its security is because it's so simplistic, but just those key pairs, and then you can add another layer of security if you want to have like a shared key that both sides have to have in order to use the public and private key pairs to talk. But we're going to set up a server, and I'm going to have a specific situation that is pretty common that I need to solve, and I'm going to use WireGuard to do that. Now, it is important to know that WireGuard doesn't really have a server and a client model. Every WireGuard machine, or every machine that has WireGuard, is a peer, and you connect to another peer. Now, usually we think about a WireGuard server as the peer that listens for people to connect and use its stuff, right? So I have a side that I'm going to call a server side and then my client side, but honestly, they're all just peers that talk to each other. So it's important to know that, but then also you set up how you use it however makes sense. You could just connect two peers, but I have like a central location and I have a remote laptop or whatever that I want to use wherever I happen to be. And so that's going to be like what I consider the client. Anyway, let me show you how it works really quick, and we'll actually set it up from scratch and show you just how easy it is to set up. So this is actually what we're going to set up. I have a data center over here, and this is the internal IP scheme at my data center. It's 192.168.5.0, meaning like 1 through or 0 through 254. And this is that's the internal range inside the data center. Now, the data center does have a public IP and there's a router in here, but basically I want to be able to access all the servers in this data center from where I happen to be, which is here, remote me on this computer over here. And my IP address, actually I'm at my house, is 192.168.1.0, meaning 0 to 254 range here. So the 192.168.1 range is where I am in my house, but I want to be able to connect to that 192.168.5 range as if I were on the same network. So that's the goal with what we're gonna set up here. So anyway, to do this, all we have to do is set up WireGuard with, like I said, it just uses keys. So I have a local public key on my side. I'm a peer over here. This public key is going to be told to the server at the data center. So the peer over here is the data center peer, and I'm going to tell it my public key, and it's going to tell me its public key, and that's how we can identify each other when we set up the tunnel. Now, the tunnel is a third IP range that we use to route traffic from 192.168.1 over to 192.168.5, okay? And in our case, that tunnel, I have it set up here 10.10.0.0, and so 10.10.0. whatever that last number is going to iterate, is going to be the tunnel that communicates between the two. It's like the tie that binds them together. And this is pretty standard stuff for VPN. That's just how VPNs work. But when we set this up, all of the traffic, when I am sitting here it's going to be a virtual machine that we set up, I should be able to just ping computers and actually SSH2 and do everything to computers on the remote 192.168.5. whatever network as if I were on that network, even though my IP address is 192.168.1. something on my end. Okay, so it should be just completely transparent. We're going to set up the rules, we're going to set up the peers and have them connect so that it works like that. Now, I did mention there is another thing we can set up, and that's a shared key. And the shared key is just that. It's called a pre-shared key, and it's something that you create in advance, and it's the exact same key that is put on both. So with the public and private, the peer keeps its private key, it never shares that, and it sends its public key over to the other peer. And then on this side, this computer, the server, keeps its private key and it sends its public key over to the peer. But the shared key is the exact same key, and they both have to have it in order to connect. If you don't have a pre-shared key, it works just fine. But if you have a pre-shared key, they both have to have it, and they both have to match. They have to be the exact same key. All right, I think that's all there is. We will set it up so that it can work, and I'll show you really quick what my setup looks like. So on this computer where we're sitting right now, this is just a virtual machine. It's Ubuntu Mate, and I called it Mate for a machine, and I'm logged in as root here. I just did sudo to become root because everything for Wireguard has to be done with root access, so I just wanted to save us time, and I'm going to be root. And if you see Mate as the host name, this is my local virtual machine. Okay, now I have another tab here that's a root at Wireguard. Now Wireguard is a computer in my data center. I'm not logged in through a VPN, this VPN, because we haven't set this VPN up yet. So I'm connected through another route that doesn't depend on this computer's VPN, but I'm connected to that remote computer, and that's where the server is going to be set up, is on this Wireguard computer in this tab. I'm just connected remotely to that computer in this window. Then over here, just as powers at Mate, again, Mate is the local VM. This is just a terminal window I have open so we can test stuff. For example, if we say ping 192.168.5.37, it's not going to respond. It's just going to say, I can't, I'm not part of that network, because, let me shrink this down a little bit. Because if I do IPA, we can see that my current IP address on this virtual machine is 192.168.1.220. Okay, so I'm on the .1 range, the data center's on .5, so right now I cannot ping it from this virtual workstation, from this virtual machine, which is kind of like my laptop, right? I mean, it would be just a remote computer on my network. We can also take this to like a coffee shop and connect to our Wireguard machine, and everything will be protected there too. That's kind of the idea, is you want to be able to connect to where your server side of the tunnel is, and be able to connect to it from anywhere. So let me clear this screen just to clear, so we know what we're doing here. And what I'm going to do is, first I will be on our Mate computer. Or no, first we'll go to Wireguard, I guess, the server, and we'll set up the public and private keys. And then we will set up public and private keys on our local machine. I'm going to write all the information down here. This is just my little notepad. I'm going to write the stuff down here, and then we'll create the config files and connect. Now, the only things we need to do to prepare for installing these things is, well, we have to install Wireguard, and it's the same pretty much in every distribution. It just, for these are all Ubuntu based, it's just apt-get install Wireguard, and you're done. Okay, so I did that in all the machines already. The other thing, though, which is not quite as straightforward, is I know that I said both sides are peers, and they are, but the server side in my data center has to be accessible via a public IP address with an open port. Okay, so there's a public IP address, and we're going to connect to that public IP address through a forwarded port into the Wireguard server. And once it establishes that, traffic can go both ways, but we have to have a way to get the connection going. And so my data center has a public static IP. That's what I'm going to connect to. And I need to have a port forwarded from that external IP address, that public static IP address at my data center, into my Wireguard server. Just one port, and it uses UDP, not TCP, UDP. It's important that it's UDP that we forward. And once you set up that one port forward, that's all we need to do network wise, and we can just get it going. I'll show you. So I'm using pfSense, and on pfSense, this is what it looks like to do a port forward. You just say like what interface, my WAN interface, protocol is UDP, and then the destination port is, I'm going to use 58123. It doesn't matter what port you use, but you'd have to remember the port that you use. I'm going to use 58123, and I'm going to forward that into my WireGuard server. And that WireGuard server internal IP address is 192.168.5.37. Okay, so that's where it's going to get forwarded to. And again, it's going to forward the 58123. So that's all you have to do to prepare. And now here we are on our WireGuard server. The first thing we're going to do is generate the keys. Now you can save these to files, and that makes sense so that you have them backed up on the computer itself. But I'm going to go into the etc. WireGuard folder, and there should be nothing here, completely empty. We're starting from scratch. And I'm going to say WG for WireGuard. That's the WireGuard main command line thing. I'm going to say gen key, okay? And it will spit out a private key. Boom, that's my private key. Now we could put this in a file and save it. I'm not going to do that. I'm just going to copy it, and I'm going to paste it right there. Let's see if we can stretch this a little bit so we can see the whole thing. Okay, and now in order to make the public key, you actually have to use the private key to generate the public key. So what I'm going to do is it's still in my clipboard. So I'm going to say echo, and I want to have it echo that key. Okay, so if we do that, it will just echo it to the screen, right? So I'm going to say echo that and pipe it using the pipe symbol. So I'm going to redirect it into standard input of the command WG pub key. Okay, and that will return the public key to us. So now this is the second thing we need to keep in our notes. We've pasted it in there. Now we can do the same thing. Should we generate the pre-shared key here? I mean, we might as well. It doesn't matter where we generate it. It's going to be the same on both. To do that, we do WG gen pre-shared key. So gen for generate, and then PS key, or PSK for pre-shared key. Press enter. This is a pre-shared key. So we're going to take this, we're going to paste it over here. Okay, and that's our pre-shared key that both computers will have to have. Now, before we do anything else, let's come on over here. You notice I switched tabs. Now I'm on the Mate computer. We're going to go into etc. WireGuard. Nothing in here again. The reason I'm in here is this is where the configuration file is going to go, but we didn't necessarily have to be here to generate the keys. Anyway, I'm going to do the exact same thing. I'm going to say WG gen key. This is our private key for the client side. So I'm going to take this, so paste that in there. And now the same thing, I'm going to say echo what we just had, so it's still on the clipboard. Okay, that's our private key. I'm going to echo that and then pipe the output into the standard, into the standard input of WG pub key, and that will give us the public key. Going to paste that into our little document over here, and that's all we need to do. Now we just need to set up the configuration files, and I didn't have to generate a pre-shared key because remember, it's the same for both. We already have it, so I didn't need to generate a pre-shared key on this computer. We generated it on the other one. So let's set up our server first, I guess. Come over here, and I'm in the etc. WireGuard folder. I'm going to create a configuration file. I'm going to call it WG0.conf. It doesn't have to be named this. This is kind of the standard default is WG0 for WireGuard interface 0.conf. On the server, I generally like to keep it that way. I like to call it WG0 just because it's the standard and it's going to be listening. And so I want it to be server-like, and I don't know, you can name it whatever you want. I just always use WG0 on my server side. So this is going to be just an empty document. And the first thing we need to do is set up the interface itself, like the part that's going to be listening. Like we need to set up this peer's information. So we do interface, which is, this is like a section, so it's in brackets. And then we have to tell it a couple things. One, the interface has to know its private key. So we're going to say private key equals, and then we're going to take the server's private key right here. We're going to copy this, the whole thing, and then bring it up here, paste it in. And now we have to tell it the address that it's going to use. And now remember I said that the VPN tunnel has its own range? That's what this address is talking about. This is not the computer's address. This is the WireGuard interfaces, like this end of the tunnel's address. So I'm going to say address equals, and it's going to be 10, what did I say in the thing? I think it was 10.10.0. something. And so I'm going to make this 10.10.0.1. And I'm going to say /24 for a 24-bit address. And so this end of that VPN tunnel is going to have the address of 10.10.0.1. All right. And then we also have to tell it what port to listen on for incoming connections. Remember that port forward we set up? So that is going to be listen port equals, looking up at my notes here, 58123. That's the port that I forwarded into this computer from the outside world. Now, we do have to do a couple other crazy things to get routing to work right, and that is going to, in fact, I will type them in and explain them afterwards. So I'll speed this up maybe and type it out real quick. Okay, and what we've done here now, this is IP table stuff, routing table information. If this is above your pay grade, that's okay, because at the end I have this fancy little website that you're going to just be able to cheat and do copy paste everything so simple that you probably wish that I would have showed you this site at the beginning so you wouldn't even have to listen, but we're going to go through it anyway. IP tables, this basically adds a rule that allows IP traffic to be forwarded for input and for output, and then it allows it to be masqueraded to the rest of the internal network. Post up means after the interface comes up. Post down means when you take the interface down, it removes all that stuff. It deletes those forwards for input and output, and deletes the network address rule for masquerading traffic to the rest of the network. Whew, if that was kind of crazy, again, don't worry. I'm going to have a really simple copy paste way for you to do this. However, there is one other thing that if we're going to do this, and I should have done this before. Let me save this file and we'll go in really quick. The other thing that we need to do is on the server, this is only on the server, so you don't have to worry about setting this up on clients. Once it's set up on the server, it's done. We also have to make sure that this kernel is set up to forward IP traffic. And the way to do that is to edit the file, etc. sysctl.conf. And it's probably not on there. You want to add to the bottom this net.ipv4.ip_forward equals 1. That all that will do is allow the computer to the kernel itself to route traffic around. So I'll put that little snippet in the description of this video file, or this video, and you just put that in, etc. sysctl.conf, save it, reboot the computer. That part is set. You never have to change it again. All right, so that's that. And then we'll go back into this WG file. All of this other IP table stuff it activates the routing, and then that's it. We're done for the interface. The only thing we need to do is set up our peer connection. Like, okay, we're listening. We have rules set up for when we're listening, but who's going to connect? And that's where we have to define the peer. Now, in our case, the peer that we're defining on the server is our remote virtual machine, Mate, right? That one that we're going to set up, actually this computer that we're on, but we're SSH'd into the WireGuard server. So we need to set up a new section, and this one, I need to hit enter there. And it's just called peer. Now you can have multiple peers configured. You just have a new peer section. So peer. And what I like to do is comment what the peer is in case there are multiples. So anything that starts with a pound symbol or hashtag for the new kids, is just a comment, so you can describe in here. So there's going to be the VM at my house is the peer that we're setting up here. And then to define the stuff that we need, first of all, we have to tell it the private, or not the private key. We have to tell it the public key of the peer, remember, because we're going to tell the other side our public key. And in this case, the client over here in our notes, the client's public key is right here. And this is how the server is going to identify the incoming peer. So we're going to say public key is equal to, and then we'll paste that in. And then we have to tell it the address of that peer. Okay, so the peer's address. But since we're talking about another peer, we're going to say allowed IPs. And this is a little bit confusing terminology because, again, every server is a peer, every peer is a server. But the allowed IPs are basically what is this computer, our server, what IP addresses is it going to use this peer for? And it's going to be that peer's IP address because it wants to talk to the peer on the peer's IP address. So the allowed IPs in our case are going to be 10.10.0.2. We're going to use .2 for our peer. And then we're going to do /32, which I know is different from the address that we set for the interface itself on the server. But what this is, the /32 means only this IP address. And the reason on the server we say only this one IP address is who we're communicating to this peer through is because if we have multiple peers, we might want another peer to be 10.10.0.3. And if we were to say that all of the traffic going to 10.10.0.2/24, like the whole range, it would send all the traffic to the first peer, and the second peer, it wouldn't. So by limiting it to saying only this single IP address, and that's what /32 does, limits it to a single IP address, that means that only the peer's IP address are what's going through the tunnel to that peer. Hopefully that's not too confusing, but when we set up the peer, we want to just have it go to that single IP address. And then even though it's optional, we did create a pre-shared key. So let's put the pre-shared key on this side of the connection. So we're going to say pre-shared key equals, and then we'll just copy and paste this pre-shared key in our notes over here. And then we're going to paste that in. So our pre-shared key is listed right there. And that's really all there is to set up. So the server itself right now is ready to not only start, but listen for an incoming peer. So let's save this file. And in order to start this interface going, we can just say wg quick, which is the tools that are supplied in Ubuntu and pretty much wherever you install it. It's going to be the same in like CentOS and Red Hat. Wg quick up for bringing up this side of the tunnel. WG0, which is what I named the file without the .conf. So WG quick up WG0, and boom, it's up. It's up and waiting to route all the juicy traffic from our VM. So let's set our VM up from scratch now so that we can connect to it. Right now, it is listening for us to connect from my Wireguard server in the data center. So now we're going to go over to Mate, which again has nothing set up yet, right? We don't have anything set up. So let's create a file first of all. And I'm going to call this one, the data center's at my farm. So I'm going to call it farm0.conf. Okay, that's what I'm going to name this interface as farm0, and we'll edit it from here. Now, again, every peer is a server, every server is a peer. So we need to start with interface. And we're defining this computer's interface. Okay, so the first thing we're going to do, and it doesn't matter what order you put these things in, but we're going to do private key equals, and we need to give it its private key, which we generated and we saved over here. So this entire thing here, paste that in. Okay, so that's our client's private key. And now the address that this interface is going to use, 10.10.0.2. Okay, remember, because this side of it is .2, the first client is .2, and I'm going to say 24. I want it to be able to communicate anywhere on this subnet, and so I'm just like I did on the other side when we set up the interface itself is going to listen on all the entire subnet. So /24, this is its IP address, and then since we're not doing any routing on this side, that's it. All we have to do on this is have its private key and its address. And that's it, okay? So now we need to set up the peer that it's going to connect to. So same thing as the other side, peer. I'm gonna say data center at my farm, again with that hashtag symbol at the very beginning. So it's just a comment. It's not parsed by anybody but our human eyes. All right, and then public key of the server, right? The public key of the server, which is right here. Paste that in. We can put the pre-shared key in now. Again, it doesn't matter what order the things go in. So I'm going to say pre-shared key equals, and it's the same pre-shared key that we used on the other side. So this is our pre-shared key. Copy that. Something we need on this side that we didn't have on the other side is where are we connecting? And that's actually called the endpoint. Endpoint equals, and this would be the public IP address that is, at the data center, right? Now, I actually have it's called just remote.ip, but this could be like a public IP address, right? This resolves for me to a public IP at my data center. And we have to tell it what port that we're going to use. In our case, it is, what was it? 58123 was the remote port. So this could be, like a remote IP, like 1.2.3.4, whatever the public IP is, or a fully qualified domain name. And that's what this is for me. This is a domain name. Remote.ip is the public IP for my data center, just so I don't put my actual IP on here to show everybody. So that's the endpoint it's going to connect to. And then we also need, for remote computers that have to tunnel through an outgoing NAT, I like to actually have a persistent keep alive setting, which basically it's not really a ping. It just like rehandshakes the remote server every so often. And I like that because while on the remote side, the server has that forwarded port, on my side, when I go out to the internet, that could expire between things that I send to the data center. So I want to keep this NAT on my side, or at the coffee shop, or wherever you happen to be. I want to keep that alive. So on the client side, I usually make a setting, persistent, and make sure I spell it right, persistent keep alive equals, and then how many seconds before, just like send a quick ping. And it's not an actual ping, but like a quick connection to keep that tunnel established. I'm just going to say every 25 seconds, just send a quick keep alive packet. And then last but not least, what do we want to use this peer for? Right? We want to connect to 192.168.5 stuff. So we have to define that. And on this side, it's going to be allowed IPs equals. And so we say we want to use this for 192.168.5.0/24. So that entire range we want to send through this peer, because that's the only way we're going to get to it. and now we also need to do one more thing, is we need to say, I want to use this peer for the tunnel, right? I want to get to the tunnel itself. So we also have to say 10.10.0.0/24. So that whole network, we also want to send through the peer connection as well. Now, I'll admit, sometimes, depending on your server side, you may not need to specifically mention the peer, the tunnel address itself, but it's always safe to do that. And I always recommend that you do put the tunnel IP in there, because sometimes it will fail if it's not listed in there. So sometimes it'll work, sometimes it won't. It will never hurt anything to have the tunnel IP in the allowed IP range here. So I just always put it in there. And then that's really it. That's all there is. Let's save this side. And now, same thing on this end, we can just say WG quick up, but on this side, now it's farm0. So we'll press that. And now it should just work. So let's try it. Let's come on over here we're just on the VM. And if you remember at the beginning of this video, 18 years ago, I did a ping 192.168.5.37, and it failed because we weren't on the same network. But now it should just work. And look at that. So we're able to ping and connect just as if we are on that network, because it is set up through this WireGuard tunnel that we have established. Now you want to make sure I'm not doing anything tricky here. We can say WG quick down farm0 to disconnect this interface. Take it down, and now if you look over here, all of a sudden packets are not going through anymore. Let's see, it's like it stopped doing that. So if I hit Control-C and I try to ping, it's not going to work because I took the tunnel down. All right, so Control-C. Now, the last thing I want to show you is how you can make it permanent, okay? First of all, over on the server, I just switched tabs. So I'm on the server over here, the WireGuard server. What you can do, and this is so cool, there's a systemd kind of like cool shortcut where you can make it come up automatically when the server boots. And to do that, sysctl enable, this is how we enable a systemd service, but it's kind of like this dynamically created service. And that service is going to be WG quick, and then the @ symbol, and then the name of the interface. So WG0. So we enable it, and now it did that symlink. Every time we reboot this computer, it's going to automatically bring up this end of the tunnel and start listening. Just automatic. out of the gate every time the computer reboots. And the reason I started down this whole WireGuard path, or when I first started, I was like, okay, I really want a GUI, on my workstation or my laptop so that I can bring up and put down the interface whenever I want. I don't want to have to type on the command line. Even though I'm nerdy, I wanted a GUI. There's a really nice GUI for Windows and OS X for WireGuard, but there really isn't a great one for Linux at all. Now, there is like a thing you can compile and sort of get it to work with Network Manager, but I don't like that at all. One, because it doesn't work on Ubuntu 22.04, at least as of right now. But it turns out if you just always leave the tunnel running, it's fine. It doesn't hurt anything. When you reboot your computer, it'll just be there waiting for you. So I do the exact same thing on my workstation, on my laptop, or whatever that I do on the server. I just use the systemd service to open it up, leave it up, start it when the computer starts, and leave it up all the time. Because every time it tries to send a packet out, it will establish that connection to the remote server, and it will just work. So nice. I set it and forget it. Never worry about it. So no matter where I am, I'm always securely connected to my data center from this computer that I happen to have. So that's just really cool. Anyway, I'll show you how to do that. Again, it's the same exact way. Remember, every server is a peer, every peer is a server. So we're going to do the same thing, but on the client side. And so we'll switch back to the Mate computer and the exact same thing. Systemctl enable wg quick at farm0. And now every time this computer starts, it's going to bring that interface up, and I'll just be able to ping every single time, and I'll be able to connect every single time, no matter where I am. It's just going to always work. WireGuard is so cool. Now, you probably remember that I said you're probably going to wish you didn't watch all this. I hope you enjoyed watching this to see how it works. But I have to admit, if you're going to set something up from scratch, you probably just want to go to this website, which is simply wireguardconfig.com. And it's all client-side JavaScript. So like the people running this website are not going to get the information that you're creating. It's all created on your computer in your browser. But basically you just fill in the information, right? So the listen port that I set up here was 58123. So if I set that up, how many clients do I want? Let's say that I wanted like, I want one for my laptop. I want one for my desktop computer. I want one for a VM for my YouTube demonstration. I guess I should have left it at 3, but we're going to say 5 anyway. The CIDR range here, this is the range for the tunnel, right? For the actual tunnel interface between them. So for ours, it was 10.10.0.0/24. Client allowed IPs. This means what I want to access remotely. So for us, it was going to be 192.168.5.0/24, comma, and I always put in the tunnel interface as well. So 10.10.0.0/24. And then the endpoint. Remember, this is where you can use a fully qualified domain name or just a raw IP address if it's a static IP. For me, the endpoint is remote.ip 58123:58123. DNS, if you want to specify a DNS, I didn't mention this earlier because it's not really important for me. However, if you are setting up something where you actually want to route traffic, like all of your traffic through a WireGuard port, for allowed IPs, you could put on the client side 0.0.0.0/0, and then all of the traffic is going to go through WireGuard, which is what you should do in a coffee shop, right? All of your traffic is going to go through something that you trust, your secure server. But the problem with that is, if you have all of your traffic go through your tunnel and your DNS server that was assigned at the coffee shop is like on their network, you won't be able to get to that network. So you can specify when this interface is up, what DNS server should I use? And so that's why you would specify a DNS server if you're putting all of your traffic through that tunnel. And so it's always safe to say like a DNS server, so like 1.1.1.1. You could always put a DNS thing in here, but it's especially true if your client allowed IP range is going to be 0.0.0.0/0, meaning everything, then you definitely want to specify a DNS server to use. And then all of the rules are right here. They're right here. You don't have to type them out. They're all right there. It's really nice. The only thing you have to watch for is on your server, make sure that this interface Like mine is ETH0 and it's listed as ETH0 right here. But if yours is like ENSP03 or something, you want to change the name of the interface here and here, just so that it works on your system. That's the only thing that you need to do. And then you can just check this box to create a pre-shared key. If you don't check it, it just won't use pre-shared keys, but you can check it, might as well, right? And then you click generate config, and that's it. You're all done. Because if we scroll down now, you're going to see, one, you can just click this zip file and download all the files, which is nice. But if you look, here is the server with all this stuff all set up for every single peer, including a shared key, pre-shared key that is set up for all the client config files, which are right down here. Everything is listed for you. The private key, the public key, and the config files themselves are all set up. It's just super, super easy to do. And this QR code is because WireGuard exists for like phones as well, Android or iPhone. And in order to install the config, all you have to do is take a picture of the QR code, boom, it'll put all that information in. And so this is such a really great website to quickly set things up, even for multiple peers. I'll put that link in the description. Now that you know how it works, you probably don't even have to set it up by hand. You can just go to that website and copy and paste everything directly into your servers. It's super, super nice. And I'll be honest, like I said, this is the VPN that I always wish I knew about. I wish I would have learned about it years ago and actually taken the time to learn, because it's so much easier to configure than OpenVPN. I know I went through a lot of detail, but really what's actually happening is so simplistic. It's just a lot of copying and pasting and understanding why this key is here and how we're connecting and all that stuff. But especially with that website, it's super simple. And I hope you learned something. I hope you use it. I hope it's useful. And most importantly, I hope that you learn everything. Do what you love. And most importantly, be kind. I'll see you in the next video.